I'll be showing two methods where you can take a data set and split that into multiple tables, where each table has at most 50 rows. So if you have 78 rows, you'll get one table with the first 50 rows and then another table with the remaining rows. This could be relevant if you have a large data set where you need to split that. First, I'm going to have a named range where I put in my file path. And this will be a named range, so I can refer to it and load it in Power Query. From there, since I know this is a CSV file, I'll open up a new query from a CSV, and right now I'll manually find this file, and then I'll adapt it so it loads from my named range instead of a fixed file. I'll be a bit lazy and cheat here and just say Advanced Editor and copy paste my code. I'm simply saying go into my current workbook, look for a named range with that name file path, open it up, and then grab it. And we can show that right in a second. I need to actually give this step a name, which would just be my source. And then in my source, I'm grabbing the value inside. Now in my source step, I need to change this step, this text bit, which is my file path, but this is fixed, and I can just change that to the name of the previous step, my source. And now I have my table, which has 1,000 rows. All I actually need to do here is to add a new column, which is a index column starting from 1. And I'm going to be using this to add a filter to my data afterward. So I can say my first table needs to have between row 1 and 50, and the second will be 51 to 100, and so on. I want to add one extra thing before I go and do the individual 50 row tables, which is I want to add a new table which will give my user an indication of how many sheets they have and how many rows they have. I'll simply add a new query, which can be a blank query, because I'll be referring to my original data set. I need to use the list max function to get the highest value from the index column. I can add that here inside of my table, so I can copy that code, which is simply under statistics and then maximum. Instead of added index, I'll need to refer to this query, which is why I need to first change the name so it's something easier to refer to and understand. Now my table is called my source, and there's no space in it, and it has a small m. Now I get the maximum value, and what you notice here is that this is 1,000. There's a bit of a problem with this method. This part can be a bit tricky to explain. Let's say I have 200 rows here. I know that I need 4 sheets for this. So sheet 1 has 1 to 50, sheet 2 has 51 to 100. But if I have, say, 78 rows, then I need to have 2 sheets. So I need to do a check here to say if this number can be divided by 50, and that's a whole number, then I know that I need the number of rows divided by 50, and that's how many sheets I need. But if I have 78 and I divide that by 50, I get 1 comma something, and then I need to round that up to 2 sheets. So I have the remaining 27 rows on another sheet. This is a bit confusing, but it's something I just need to do. Otherwise it will run into a problem when I have exactly 50 or exactly 100 rows. So at this point I need to add a new column, which I can't do right now because this is one value. So I'll need to add a new step and then copy the code. And what I need to do is I need to divide this by 50, but then I need to do a rounding down, which is just called the integer divide. So this will, if I have 78 divided by 50, that will give me 1 comma something, but I need that to be rounded down to 1. I could also divide it by 50 and then round it down to a whole number, but this works just as well. So right now I just need the code so I can copy that into a new step, which is here, number.integerDivide, and then the value, and then comma 50. And then I can delete that step. And now I just copy that and say that instead of saying it should be the current row, it will be my source step, which is 20. And then I need another in-between value to work with, where I just normally divide it by 50. And then I need to check if those are identical. And in this case, they are identical, which means I know I need to have, 20 sheets. But if this was, say, 991, if I were to just keep rows and I say I only want the top 999 rows, then these will be updated. So the integer divide will be 19, but I don't need 19 sheets. I need actually 20, so I can have the last 49 rows in its own sheet. And now these two numbers aren't the same, but they are the same if the number can be divided by 50. And that means I need an if statement, which is simply if my two numbers are the same, and it would help if I gave this a better name. If those two numbers are identical, then I know I need that number of sheets. And if the two differ from one another, then I need actually the number of sheets that I get from the integer divide and then add 1 to it. Because again, if I have 999 rows, I actually need 20 sheets. So the last 49 rows will be in a sheet. Now all I need to do is to add a table, because that will be a bit easier to read. Now I'm going to close and load, and that will be because that will make it a bit easier later on when I have to make a bunch of tables. Query 1 now needs to be loaded into my front page. Now the user can say, okay, I have 1,000 rows, which means I need to check 20 sheets because I will have a lot of sheets down here. I will need to make more tables than I actually need because I might have a varying amount of rows each time. So let's say I know I can never get more than 1,000 rows. That means I need 20 sheets down here to pick from. But maybe this can change, so sometimes it's 400 and sometimes it's 800. Then I need enough sheets to handle every single situation. You need to know how many rows will I actually have. And then at this point we can go back into Power Query. What I need to do now is simply to reference the original, where I have all of my data in, and apply a filter on my index row, or index column, where I need the value to be between 1 and 50 for the first time, and then it needs to be between 51 and 100. So it needs to be greater than or equal to 1 and less than or equal to 50. And we can check here that this is between 1 and 50 inclusive. And I can change that name to be 1 to 50. Now I simply need to copy paste this a lot of times, again, as many times as I need. Yeah, I need to have more tables than I think I need. If I think my maximum is 400 rows, then I need to add enough to handle maybe 500. And I need to change both the name of my table and what my filter is. So that will be 51 and 100. And I'll be speeding through this so you don't have to watch that. Since I'm lazy, I'll only be showing this small version of my actual final product. Again, there's no real point to do more work. Here I need to do close and load, and I want to say that they should all be turned into tables, which they are. And at this point you'll want to go through and check that the sheet 2 has row 1 to 50. And you'll need to update the name again. Again, here sheet 3 has the table 51 to 100, and again you can check the index So you can always go back and say, hey, I think something is wrong. Well, go and check this then. You can always go and check the original data. The nice part of this solution is that everything is contained inside one sheet. All you actually have to do is to change the value in this cell and then hit refresh and everything gets updated. And if you have, say, if you don't have 200 rows, then this table will simply be blank, which I can show. If I go back in here and add a filter to my source, say I only want the first 150 rows, or maybe 144, just to see that it works. Then the first table will work just fine, have 1 to 50. Second is also fine, and then the third one will have 101 to 144. And this is blank, and this is blank. And when this is done updating, we have a smaller table here. Yeah, I needed to update all actually. And now it's updated. Yeah, so 0 rows loaded, 0 rows, and 44.